Okay, so what we're going to do here is create a new class, a new data type if you want for Python to work with, a class of fractions. I'm using Google Colab for this, but any Python interpreter will do for this. There's nothing special about Colab for these purposes. Before I can get started with this, I need to create a highest common factor helper function. So let's have a go at that. The standard algorithm for this is Euclid's algorithm, which is 2,500 years old. There are plenty of other ways to work out the highest common factor for a number. Let me give you an example of Euclid's algorithm. So if I said, what's the highest common factor of 15 and 21? You know that 3 is the largest number that goes into both 15 and 21. But Euclid's algorithm says, put the smaller number into the larger and have a look at the remainder. So 15 into 21 gives us a remainder of 6. Now replace the big number with the small number and do the same thing again. So 6 is our new number, so we're looking at 15 and 6. How many times does 6 go into 15? Twice, forget about that. The remainder is 3. So again, replace the bigger number with the smaller, so we're looking at 3 and 6. 3 into 6 goes perfectly, no remainder. So step 1 back, that number that you divided, your last one you tried by, is the highest common factor of the two numbers, and that's absolutely spot on. So we could attempt to define this. So let's define a new function called HCF of A and B to be equal to, well, the highest common factor. So we want to return the value which we get when applying the function again to something new. So we do the smallest first number into the second number, b%a, take the remainder, which is what our percent modulus operator does there. There we go. And then replace the bigger number with the smaller of those two original numbers. So that actually is syntactically correct, but there's going to be a problem with that. So what happens here, I do HCF of, I don't know, what is it, 15 and 21, and it crashes horribly, saying it's attempted to do a modulo division by 0. The problem is we've not given it any exit condition. When I get to one of those numbers, the first number is 0, then that's enough, it really is. So we need to put a test in here. Recursive functions typically have this sort of thing going on here. If a is equal to 0, then return the second value b, else return what we had originally. Okay, let's try that again. And this time we should get the answer 3 back. Indeed we do. That's a relief, isn't it? Okay, so we've got that little helper function going on now. Anything in there which gave the highest common factor would work. I've just done Euclid's algorithm, but you could write your own algorithm for finding highest common factors. For instance, list all of the factors of A, list all the factors of B, find the largest number that's on both lists. That's a really slow algorithm, but it will get you there in the end. So there are many different algorithms for finding highest common factors. Let's have a go at creating this class of fractions now. So first thing which I'm going to do is say this is a new, this is a new class. Think of it, if you will, as a data type, as something in which we can store information, but also something which has particular operations that we can perform on it. So let's have a go at fraction now. So my class of fractions, I've got to define a number of methods on this, and the first of these is what we call the constructor method. And the standard approach in Python here is it's this init thing, which is how we go about creating a new fraction. And we're going to have it referring to itself. So this particular fraction, the first parameter of all of these, you think of them as procedures or functions that we apply to these objects, starts with self here. And then we've got the numerator of that and the denominator of that fraction that we pass it. And how do we create this fraction? Well, there are a number of things we're going to do. First thing we're going to work out is the greatest common divisor, the largest number that goes into both the numerator and the denominator. And that's why we've got a little helper function running already. So the highest common factor of the numerator and the denominator. Good. Okay, so that's going to be useful. And then what we're going to store is the top and bottom of this fraction. So the top of the fraction, my keyboard has frozen. top. the top of the fraction is equal to what you get if you take the numerator we've been given and divide by the greatest common divisor. The bottom that we store is what you get if you take the denominator that we're given and divide by the greatest common divisor. So I'm storing a fraction in its simplest form, and there's a unique expression for that, whereas there are lots of fractions which don't have a unique expression. So for instance, 15/21 is exactly the same fraction as 30 out of 42. It's exactly the same fraction as 5/7. So we want to store a unique form of this, which is the fraction in its lowest terms. Dividing by the greatest common denominator gets us that. Shift return to type that code in. And Python comes back with no error messages, which is always a relief. I can now create a variable, let's call it a, to be a fraction equal to 15/21. And we get no complaint back from the interpreter, which is really good. Can I print the value of a? It says it's a fraction, so it's not giving us very much information. We've got input, we've got no output for this data type, this class at the moment. So let's have a go at that. And the standard method here is this dada str operator, which will cast a particular object as a string. That can be very useful, and that's also called by the print function there in Python. So we take just the fraction itself, the self, that particular object, and we define this string operator to return concatenation. So we take the string version of the top, so I do self dot, keyboard keeps freezing, top, I concatenate with a solidus, and then I concatenate with the string version of whatever's on the bottom of the fraction in its smallest terms. No error messages. A is still 15 out of 21, that's good. Let's see what happens if I ask it to print A this time. And we get a response 5 out of 7. That's pretty cool, isn't it? It's saying 5.0 over 7.0, which is really quite inelegant there, because I don't really want this being displayed as real numbers. The issue, of course, is that I've done a division here, which will always return, which will typically return a real number. If we do integer division, true division, then we should get something. Let's redefine that and test it with my printing whatever A is. 15/21 is 5/7. It returns with the correct thing. So that's looking pretty good so far. We can define other methods of our own devising on this. So for instance, I can create a method which doubles my fraction. Think of this again as a function or a procedure. It takes whatever fraction it's given and doubles it. And this is going to return a new fraction. So I can call the fraction class from within the fraction class, equal to 2 times the numerator, so that's self.top, and the same denominator, self.bottom. Okay. So I've got print A, and now let's try print double, A doubled. Okay, so that applies a method to an object, and this dot notation is standard across a lot of languages for objects. So A is an object, it's an object of the class fraction. We're applying a method for that class to an object in that class. This is treated as a function, so we pass it no parameters, because all it needs is which it's being applied to, but the syntax matters here. So I should get the answer 5/7. I don't know, 10/7 coming out of this as double that fraction. Oh, it didn't like that. A dot double. Fractio is not defined. Did you spot that as I was going through? I hope you did. I didn't, obviously. And 10/7 comes back out of that. That's really nice, isn't it? Okay. We could generalize this, so I could have def multiply by, do we not do an underscore? Camel case, I guess. No, for Python the standard pep8 is underscores, isn't it? Multiply by. So this time it's self and the multiplicand. Do we the number? Okay, it doesn't like number. I'm going to call it n. So whatever we're asking it to multiply by, we're going to call that n. And we return something very similar to what we had earlier, the fraction, fractio, and then n times the self.top, comma, self.bottom. Okay. So I've got print a double, then we can do the same thing here, print a dot multiply by, and then let's give it another thing in there. So if I give it 7, that should be interesting. So we have what's 5/7 times 7. I should get the answer 5 coming back out of this. Let's see how that actually gets displayed, shall we? Okay, 5/1, which we can call 5, I'm sure. You could faff around with this returning thing here. So if we wanted to def the string method here, we could say if self.bottom is equal to 1 exactly, then just return the string version of self.top. Else return what we had earlier. Okay, run the code. Don't know if I did. Okay. I was expecting it to say something or to change that number. There we go. Okay, shift return. And then, so this time we should get 5 on the last line of that if I've not made any syntax errors there. That looks slightly more elegant for the answer to what you get by. You could do a similar sort of thing here if you wanted. You could display 10/7 as 1 and 3/7. Let's do that now. Sorry, I get excited about these things. So, if the self.bottom is greater than self.top, we'll leave that. The first one's working fine. Else if self.top is greater than self.bottom, then what do we return? Then we return the string version of the true division of self.top by self.bottom. So how many times does the bottom go into the top? Plus the fraction you get where the string version of the fraction you get when you replace the numerator with the remainder. So we do self.top percent self.bottom and then keep the denominator the same. I'm really scared. I should have tested this, folks. Else return the usual form. Okay, so shift return. Else if. Sorry, my mistake. Too much elif. There you go. Too much JavaScript recently. Okay, it's not happy about that. Okay, we've got a syntax error here. That's because I've got the wrong number of brackets. That should. Let's try that again. Okay, code runs, class is defined. Now we should be seeing 5/7, 1 and 3/7, and 5. I've got a little bit of a worry about how this is going to be displayed. So I'm going to put a space in there in the middle of the concatenation. Oh, I think it's shift return to make sure it takes. 1 and 3/7, 5. That was far too much faff for just social niceties of displaying mixed numbers correctly. Okay, so all of that seems to be working. We've got multiply by is working. We've got double is working. Now the multiply by and the double, that's helpful, but it's not really implementing fractions as a whole new data type. So let's see what we can do about that. So let's start by defining addition here. So I can define addition as taking two fractions, the self and the other. It's very philosophical, isn't it? How are we going to add two fractions together? Well, we are going to work out a new numerator. So new top and a new denominator, new bottom. And my new top is going to be equal to. Now you've got to remind yourself of how you did fractions back in the day. But if you sort of do a cross multiplication here, if you take the top of the first times by the top of the bottom of the second times and add together the top of the second times by the bottom of the first, that's like timesing everything so that you have a greatest common divisor on the bottom. I'm not sure, is that greatest common denominator on the bottom there? This comes back to me, it does. So we're doing self of the top, and we're going to times that by the other's bottom. We're then going to add on to that the other dot top times by the self's dot bottom, and that should work out the new top number. The new denominator is simply what you get when you times the two denominators together. So I've got self dot bottom times by other dot bottom in there. But Miles, shouldn't you have this in its simplest form? Yes, of course I should. But by casting this, by making this a new fraction, I get that for free because my fractions are defined to be in their smallest terms. So I'm going to return here a fraction made up of the new top and the new bottom. And that, with a little bit of luck, should work. Okay, so let's now print. And what we're going to do is add those fractions together. So I'm going to do my 5/7, which is A at the moment, you'll remember, and then apply to it the method add. And then we're going to add another fraction to that, and that's going to be the fraction, I don't know, like 3/5 or something. 5/7 plus 3/5. 25, 3/7, 5/7, 3/5, 20. I can't do it in my head. We're going to trust that the machine gets it right. Okay, I could spend some time working this out. Let's see what happens. Oh, unexpected end of file. I think that's a bracket issue, isn't it? Okay, 1 and 11/35. There you go. It must have been. It wouldn't have made a mistake like that, would it? Okay, so we've got something that looks like fraction or addition working. So if I was to add to my 5/7, 2/7, I know what the answer to that should be. Should get the answer just 1 out from this, and lo and behold, we do. If I add 5/7 to another 5/7, I should get 10/7, 1 and 3/7. It does look as though we've now got fractions addition working. This, on the other hand, is just a horrible bit of arithmetic, isn't it? It really is very, very awkward here. We can make it slightly more elegant, so I should be able to do print fraction, I don't know, 3/4 dot add fraction. Let's do 1/2. Okay, and close the other bracket there. I get 1 1/4. It's getting the right answer. It's just syntactically, this is horrible. Fortunately, we can overload the traditional addition operator, which is defined well for both strings, which is defined well for integers, but it's also defined for real numbers. And in Python, it's defined for strings as well, to apply to my new class fractions. And we do this with the da thing there to overload our standard addition operator. So now this here, I could just do print a plus fraction, what did we have? Let's have 2/7 going into that. And that should give us the answer 1 at the end there. Oh dear. Okay. Did I not enter that code. I didn't enter the code. I didn't redefine the class. And we get the answer 1 coming out of this. Okay, so all of this horribleness here, I could simply have, well, actually I don't even need print when I'm working in the interactive shell, plus a half, and we should get the answer 1 1/4 coming out from this. Okay, yeah, right, because it says that's actually just a fraction object. Fraction, print 1 1/4 pops out very nicely. We could cast it to a string there. Okay, we can go on and define some new methods here. So we could have defining subtraction. The code word for subtraction is sub, like that. I'm just going to have this pass, which means don't do anything. You can see where you're going with your exercise now, can't you? I can define multiplication for this. Multiplication is quite nice. So again, we're going to have self and other coming into this. And what are we going to have for self and other? We are going to, how do we multiply two fractions? We times the tops together and we times the bottoms together. So using the same idea as we had earlier, the new top is self.top times other.top. The new bottom is equal to self.bottom times other.bottom. And as before, I just return a fraction made up of those. Fraction new top. I could just copy the code, couldn't I? And the new bottom. Okay. So multiplication should now work. I've gone straight to the overloaded version of the operator. Shift return to redefine the class. Didn't like that. Define sub. Oh yeah, I needed to pass it a couple of parameters, didn't I? Self and other. Okay. Subtraction won't work. I'm not actually doing anything at the moment with subtraction, but we should be able to get it to do something with multiplication here. So I should be able to do fraction half times fraction 3/7. What's a half of 3/7? It should give me the answer 3/14 on the last line there. And indeed we get 3 out of 14 coming back. I think that's really rather nice, but then again, I'm easily satisfied. We should be able to define another method for division. Now with division you want to be careful because it doesn't really make sense to divide a fraction by a decimal. It does make sense to do a fraction divided by a number, so you could have, just as we had multiply by, we could have a divide by, but typically we're going to want to apply this to a couple of objects within this class of fraction, and what we're looking at there is trueDiv as the code for our operator. So trueDiv of self and other is defined as, and you know what I'm going to do, I'm going to make you do the work for that. There's another whole class of operators that we can do for this. So we can, what we can do is look at implementing comparison operators for this. So I can, for instance, define less than operator, again for self and other, and we need to think a little about how we would understand that. Well, it's actually very similar to what we have going on with that sort of cross-product addition approach of times the top of one by the bottom of the other, if you think about it. So what I'm going to do for this is return a Boolean value. And my Boolean value is going to be whether the self top times the other bottom, other dot bottom, is greater than the other dot top times the self dot bottom. And that should give us true division out of this. Sorry, this should give us a true less than comparison out of this. I kind of want to test this at this point. Okay, let's see what we get going on down here. So, for instance, I could ask it, is fraction 3/4 less than fraction 1/2? And we should get the answer false. Interesting. Oh, yeah, okay. You should have spotted that as I was going through. I typed the wrong symbol in there, so that was totally the wrong way round. It had a 50-50 chance, didn't it? Is 3/4 less than 1/2? No, it isn't. Is 3/4 less than 11/2? Yes, it most certainly is, which comes as a relief, doesn't it? So we can now overload the other operators in here. So we've got a less than. I can define that as I can define a greater than in much the same way. Sorry, missed the bracket. There we go. And I am going to try and remember to copy and paste here. So let's take what we've got. Again, this is returning a Boolean. That's what we had before, is equal to that. Equals is relatively straightforward. So I think equals is relatively straightforward. So defining equality. For self and other. I'm going to do it exactly the same way, aren't I? So I'm going to say if the self of times the top is equal to the other's top times, you know what I mean. So is equal to, then that should work. Oh yes, of course, double equals in there. And again, we can do some testing of this. So I should be able to say, is fraction 4/5 greater than fraction 4/7, and expect the answer to be true. I should be able to say, is fraction 3/4 equal to fraction 6/8, and I should get the answer true for that as well. So I'm expecting true, true, and true. Let's run it and see what happens. Oh, yeah, okay. I've got to. It just does the last one, doesn't it? Okay. I'm going to pause this to answer the doorbell. So that was my Amazon order. Let's finish this off now. Print fraction is equal to. And they are all indeed true. If I change this so that instead of 4/5 I asked for 4/11, then the middle one should flip over to false. Good. Okay, so we've got comparisons working. There are two more comparisons which we ought to add into the mix here. So we really ought to do a less than or equal to. So let's define less than or equal to self and other to be equal to return whether self is less than other, or self equals other, and that should be able to cope. And I can define greater than or equal to be for the same thing, self comma other to be much the same. So I'm going to return. There are other ways to do this. It's occurring to me now, whether self is greater than other or self equals other. Okay. I think that should have worked. Let's just try those out. Let's just see whether they work with greater than or equal to. If it actually does manage to apply those, that seems to be right. So 3/4 is less than or equal to 11/2, but it is also less than or equal to 6/8, whereas 6/8 is greater than or equal to 3/4. So I should be getting true for all of these now. Good. And if I said strictly greater than 3/4, that middle one should flip to false, which it does. Good. So that seems to be working, which is a great relief. Now, the joy of this, once you've defined those comparison operators, you can start doing sort on these things, crazy as that sounds. So I'm going to create a list of fractions here. List of fractions to be equal to, let's make it a list. So I've got fraction 1/2 and fraction 3/4 and fraction, I don't know, 2/7 in there. Okay, so that all looks hunky-dory to me. Let's get that back. So print list. Can I do this? Let me just see what list of fractions returns. Oh, it just tells us that we've got 3 objects in the list. This is a little bit tricky, getting this back out from a list. So what I can't do is print list of fractions, because it's just going to return pretty much the same thing here. Okay, it says there's 3 fractions objects. Remember, we need to apply the print method to each of those in print function to each of those in turn. Now we've got a way of doing that, which is using a higher order function here. So what I can do is map my print statement to all of the things in that list of fractions. Oops, list of fractions. But this also is unhelpful because it just returns a map object. What I want is that returned as a list. So take each thing in that map object and print it out one at a time. And I think this should give us, yes, indeed, that list back. It's done something a little bit weird with the non as it's attempted to apply that. I think if I type in print list map, we get something which looks more like an actual list. I may well have crashed it at this point. Okay, it's not doing anything special with that. We were better off with just keeping the list there. Okay, so we've got our list, applying print to that list of fractions. Good. Okay, so now what we can do is take our list of fractions and sort it out. So sorted list is equal to what happens if we ask for sorted, the function, to be applied to our list of fractions. Okay, and then I should be able to do the same thing here to sorted list. And get back from this, hopefully, the fractions in order: 2/7, 1/2, and 3/4. 2/7, 1/2, and 3/4. It's worked. We've been able to take Python's algorithm for sorting lists and apply that to a whole new class data type by just defining those comparison operators. It would have been interesting to see just how many of those comparisons we needed to use in order to be able to apply that sorted function to it, that sorted method to our new list. I am going to stop there. There's a little bit of work for you to do here. So you'll recall that on this version, I've just not bothered to do subtraction and I've not bothered to do division. I think it would be really nice if your little exercise to follow this would be to try and get subtraction first working, and then if you can get true division working for this as well, that would be great. I am going to stop the recording now.